Ocean features and water. Water. There's water everywhere. Earth is covered in 70% of water. 70% of the entire Earth is water. All right? It's not land, it's water. Most of Earth is water. We're gonna watch this video to start. We have 5 oceans. I know you're like, wait, Ms. Farmer, you just said most of the Earth is water. Yeah, most of the Earth is water, but it's broken down into only 5 oceans. So we're gonna watch this video, learn a little bit about the oceans, and then I'm gonna actually show you a different map of the oceans so that we can reflect on it as we continue on with the rest of this lesson. Okay? It's real quick. It's only a minute long. Ready? Let's start.
Often called the blue planet because its most distinguishing characteristic is not its continents, but its oceans. One ocean alone, the Pacific, could fit all the continents within its borders and still have room to spare. Besides the Pacific, there are 4 other oceans: the Atlantic, the Indian, the Arctic, and the Antarctic. Together, these oceans and some smaller seas form one huge body of water that covers over 70% of our planet's surface and contains 97% of its water. Yet, for much of human history, people viewed the oceans as mainly boundaries marking the edges of the continents. For the most part, people could only imagine what secrets were contained in the ocean depths.
Like I said, super quick video. So quick it caught me off guard. Sorry guys. Alright, moving on. How much of the Earth's water do the oceans contain? 97%, which means the oceans, which take up 70% of the world, of this Earth, all of the water in these oceans is 97% of all of the water on Earth. So like the little lakes and the little streams and stuff that we have only make up 3%. That's it, just 3. All right, we're gonna be using this in a minute, so we're just gonna hold on to it. Scientists have classified the world into 5 separate oceans. Do you know what they are called? You should. We just listened to the little video telling us what they're called. We're going to learn a little bit more about each of them. So first we have the Pacific Ocean. The Pacific Ocean lies between Asia and North America. So it's on like, when you got a globe, it's on this side. It's in between these 2 places. It takes up that space. So here it looks like it's 2 different oceans, but it's not. It's between those 2 because our world is a circle, not a flat piece of paper. Okay? It's the largest of all of the oceans. The Atlantic Ocean is right here in the middle of North America and Europe and Africa. It's right here in the center. It's the second largest. That's good to know. When you guys go to the beach, whether you're going to the beach in Puerto Rico or you're going to the beach in New Jersey or Virginia or North Carolina, anywhere you go to the beach, as long as you're not going across the country, you're going into the Atlantic Ocean. All right. The Indian Ocean is down here. The Indian Ocean is between Africa and Asia. It's all this area. And Australia, sorry. It's the 3rd largest ocean. So far we have the 1st largest, which takes up 2 sides of the map. 2nd largest, 3rd largest. The body of water between Europe, Asia, and North America, north of the Arctic Circle, is the smallest ocean, and it's called the Arctic Ocean. All the way like up here at the very top. I know it looks like it's the largest because it's all the way across, but there's not actually a whole lot of space up there, which makes it the smallest ocean. Because remember, circle is just has it all spread out, alright? And here they're calling this the Southern Ocean, but it's also known as the Antarctic Ocean, surrounding Antarctica. Wow, shocking, right? Regardless of whether you're going to be calling it the Antarctic or the Southern Ocean, it is in the southernmost hemisphere of the Earth. It's right here. It says scientists designated it as the unique ocean in the year 2000, so it's the most recently named ocean, which is kind of cool. They didn't used to have it as a named ocean, I guess, but now they do, which is awesome. And this is a little bit better of a map showing you, but again, you can see Pacific looks like it's on 2 different parts. It's not. It's just because that's how it works on the globe. If we turned it, you would see mostly water on that one section. The Atlantic, the Indian, the Southern, and the Arctic. All of your ocean formations. Okay? People who study different parts of the ocean are called oceanographers. They get to study things, they get to learn things about the ocean, and it's a really cool job. They can use sonar, they use different machines and submarines to go down and view the ocean and see as far as they can. They get to explore things that people have never seen before. There are some really, really exciting parts about this. We're not going to focus too much on oceanographers and studying of the actual ocean right now, because that's not the whole point of what we're doing here. So we're going to kind of skim over this. If you want to learn more about it, feel free to. So you guys had an assignment yesterday that hopefully you completed, and if you didn't, that's okay. You'll have time to get it done today and tomorrow. It's interviewing an oceanographer, but we chose an aquarist, which is a human who works with an aquarium, with the ocean life and the wildlife of aquariums, because they're more easy to come by than an oceanographer, okay? So you had that activity. If you didn't do it yet, get it done. If you have any questions on it, please ask. It's not too difficult, but there are some parts that you're like, wait, I don't understand what I'm doing here. Basically, anything you want to know about an aquatic lifestyle, whether they're in the ocean or in an aquarium, that's the first slide. You're going to write down all your questions that you possibly have for them. Then you're going to research and see what, oh man, I just lost the word again. What somebody who works in an aquarium deals with on a daily basis, and then you're going to tell me some of those things. And then you're going to observe an aquarium, and then you're going to tell me in a paragraph, 5 sentences put together, 1 paragraph, what you noticed or what you observed in that time watching the aquarium. Okay? Submarines and sonar. So in the ocean, it's not all flat. It's not just one layer. Just like the earth is not flat, it's not one layer. There's mountains, there's valleys, there's dips, there's bumps, there's bruises. There's things on the earth that change the landscape. The landscape of the ocean is also different. I know when you look out and you look at the ocean, it just looks like the water's flat. And the level is pretty equal, but underneath it changes so drastically. Just like how we have huge mountains and super low valleys, and we have Grand Canyons. The ocean has basically, I don't want to say the same, but very similar features. They have super deep valleys, which are basically high mountains reversed, right? They have peaks, and they have different sizes of things in there. So we're going to watch a quick video about that, and then we're going to keep moving on, okay?
Plankton and most other kinds of marine life exist in the top layer of the water, within a few meters of its surface. This layer gets the most light and heat from the sun. But light from the sun's rays decreases rapidly as you go deeper into the ocean water. Most of the ocean, in fact, is totally dark. As you descend into the ocean, the water temperature also becomes colder. And there's another change that occurs the deeper into the ocean you go. The pressure of the water increases rapidly with depth.
A simple experiment demonstrates the effects of water depth on pressure. Poke 3 holes in the side of a milk carton, one near the top, one halfway down, and the third near the bottom. Fill the carton with water. and observe the streams of water that escape. The stream at the bottom is the strongest because there is greater water pressure at the bottom of the carton than at the top. Pressure is measured in pounds per square inch. Standing on land at sea level, each square inch of a person's body is being pressed by about 15 pounds of air. At 5 meters, or about 16 feet below the ocean surface, the pressure from the weight of the water is much greater, enough to make a diver's ears begin to hurt. Scuba divers can swim to depths of only about 75 meters, or about 245 feet. Beyond this depth, the pressure would squeeze against the divers so hard that it would be difficult for them to breathe. Most submarines dive to only 465 meters, or about 1,500 feet. Much beyond this depth, the pressure would be great enough to crush a submarine's hull.
There are, however, special submarines called submersibles that are designed to resist great pressure. This is the Alvin, owned and operated by the Woods Hole Oceanographic Institution in Massachusetts. The Alvin is used to explore to depths as great as 4,000 meters, over 13,000 feet. Submersibles like the Alvin have allowed humans to explore areas of the ocean depths that were previously unreachable. One of the things they found is that even here life exists, like this lanternfish, whose soft, flexible skeleton can resist great pressure. Like many deep-water fish, the lanternfish is bioluminescent, which means that its body contains chemicals that give off light.
The flatness of the ocean surface is broken only by waves, but the surface disguises features that are as diverse as those found on land. Scientists have been able to map the ocean bottom using sonar. A sonar device on a ship sends sound waves through the water. These sound waves bounce off the ocean bottom and back to the boat. By measuring how long it takes for the sound waves to return, researchers can tell how deep the ocean is. Satellites provide another way to study the ocean bottom. Using computers, scientists can analyze measurements made by satellites of the height of the ocean surface. These measurements indicate bumps on the surface caused by mountains on the sea floor. Valleys and canyons, on the other hand, cause slight depressions on the ocean surface. Using information from satellites and sonar soundings, researchers have drawn maps of the ocean bottom. This computer-generated image shows what the Earth would look like if its oceans were drained of water.
The part of the ocean floor with which we are the most familiar is the continental shelf. The continental shelf is part of a continent that is underwater. It extends out from the shore in a gentle slope. This is one part of the ocean that you can partly explore on foot by wading out into the water, as these students are doing at Calmsford State Park on Long Island. Along the continental shelf, there is an abundance of sea life, for here the water is shallow and gets a lot of light. By dragging a net carefully through the water, you can see some of the kinds of marine life that live close to shore.
All right, you're going to get the fish in the bucket as quick as possible, otherwise you might stay back up the wall.
The catch here includes tiny hermit crabs and baby flounder.
At the end of the continental shelf, the ocean bottom drops off sharply. This part is called the continental slope. Beyond the slope are large flat areas of the ocean floor that are called the abyssal plain. However, in some places, particularly the Pacific, the continental slope ends in a deep trench. Scientists believe that the Earth's surface is made up of large plates or sections of rock that are constantly moving. Trenches are formed when two plates collide and one moves under the other. Some trenches are thousands of kilometers long and are the deepest places in the oceans. The deepest trench of all is the Marianas Trench in the western Pacific. In places, it reaches a depth of more than 11,000 meters, or about 36,000 feet below the ocean surface. From its lip to its bottom, the Marianas Trench is several times deeper than the Grand Canyon.
Along the ocean bottom, there are also long mountain ranges called mid-ocean ridges. The Mid-Atlantic Ridge stretches down the middle of the Atlantic Ocean and is only one part of a ridge that winds its way around the Earth. Ridges are formed where two ocean plates are moving apart. Here, magma, or hot liquid rock, from deep within the Earth, seeps out between the plates and then cools to form new crust. Near mid-ocean ridges, the Alvin has found hydrothermal vents, cracks in the ocean floor where hot, smoky water shoots up. This water contains hydrogen sulfide. Amazingly, even here there is life. Bacteria absorb the hydrogen sulfide for nourishment. These bacteria, in turn, are food for other living things, including these giant tube worms. The living things that exist at ocean vents are different from all other kinds of life. Other living things depend, either directly or indirectly, on the sun for energy. Through photosynthesis, plants use the energy of sunlight to manufacture their own food. And animals either eat plants, or they eat other animals that eat plants. But the life that exists at ocean vents depends not on the sun for energy, but on chemicals from the Earth. The discovery of these unusual forms of life emphasizes how much we still don't know about what goes on in the deepest reaches of the oceans.
There's so much that we don't know about the ocean. It covers 70% of our world, and we can't even explore all of it. So that's something that maybe you want to do when you grow up and have a job. And we learned a little bit about the continental shelf, which is where we can go out and we walk. When you're going in the water, you're on the continental shelf. The continental slope, which is, I think, a weird word for it, is where it really drops off. It doesn't really slope, it kind of drops, right? And then we have the continental rise, where things are slightly sloping together or apart. Okay? Let's move on. Let's do a quick review. A steep drop off about 100 kilometers from the shore is the continental shelf, the continental slope, or the continental rise. If you said the continental slope, which is the weird name because remember, it's a steep drop off, but it's called a slope. Weird, but I'm pretty sure we're right. Let's check it. What up? Let's keep going. The gently sloping, smooth surface feature that consists of thick deposits of sediment is going to be the continental rise. Remember, we heard about that in the movie, in the video. Look at that, awesome. And finally, the place where the land meets the sea and continues underwater in a broad, shallow plain is called the continental shelf. That's where you get to play in the ocean when you go to the beach. Look at that, 3 right, 0 wrong. We're rock stars. We're going to use these flashcards to prepare for the quiz. So, I'm going to sit for this, and we're going to go over it one at a time, and I'm going to have my computer on my lap. All right? This is where the land meets the sea and continues underwater and wears into a broad, shallow plate. Right away, you should know what this is. We just answered this one. This is where you play. What is this called? Very good. It's the continental shelf. Go work. Next, this area marks the edge of the continent, and it's steep drop from the shore. What is this called? Good, remember it's a deep drop, but we call it the continental slope. Awesome. A gently sloping smooth surface feature that begins where the continental slope ends and consists of thick deposits of sediment. The continental rise, right? Because even though this one talks about sloping, this is rising up, okay? It's a rising slope, so rise. What is found at the depth of around 5.2 kilometers? Do you know? Astronomers get this one. The ocean floor! 5.2 kilometers, that's how deep most of the ocean is. Maybe not most of it. A majority of it, how about that? Long chains of underwater mountain ranges that extend for hundreds or thousands of miles and kilometers along the seafloor. What is that called? Mid-ocean ridges. Alright, where there's mountains, it's called a ridge. So in the middle of the ocean, it's called a mid-ocean ridge. Plain and simple. Where is the Atlantic Ocean located and how does it compare in size to the other oceans? Oh man, the Atlantic, that's the one in between the United States and Europe. That's the one in the middle. Is that the biggest, the smallest, second biggest? The Atlantic Ocean is between Africa, Europe, and North America and South America, and it's the second largest. Very good, second largest. Where is the Pacific Ocean located and how does it compare in size? Well, you should know right away that the Pacific is the largest, and you know that it's between North America and Asia, but remember the opposite sides, right? There we go. And it's the largest ocean. Where is the Indian Ocean located? Guys, this one should be kind of easy for you. This one is between Africa, Asia, and Australia. I should be showing you guys. Sorry. So this was the Indian Ocean, right here, the one we were just talking about. The Pacific is here and here, remember? And the Atlantic was the first one, the second largest. It goes in this area, right there. Where is the Arctic Ocean located and how does it compare in size to the others? Arctic. But remember, even though it looks super big on the map, it is the smallest. Very good. And where is the Southern Ocean located? It's also known as something else sometimes. It's called the Antarctic Ocean or the Southern Ocean. So it's located in the south. Very good. Oh, we were supposed to put those. My bad. Alright. Now it's time to take your quiz. Because you already did the activity, so you're going to go right to the quiz. Do your very best. And don't forget to submit all answers when you're finished. Any questions, comments, or concerns, just stop the video and ask. Alright? See you guys later!